So at this point, we've looked at if then else nesting, and if then else. We've looked at most common and language agnostic type of operators. What I mean by that is the comparison, logical, and arithmetic operators that we've seen so far. They are pretty much used and understood in almost every language. In fact, every language that I know of, every programming language that I've used or that I'm familiar with in some way, uses all those operators as well. And the assignment operator, that equal sign assignment operator, it's pretty global as well across all programming languages. Now we're going to go ahead and start looking at some of the more structure word specific features and plain English or structure word script specific features and specific operators as well. So I'm going to go ahead and add another numeric output. I'll call it, let's see, perhaps bind status. And then down here, I'm going to add some extra logic. Okay, so what we've done right now, actually we're not using the bind status variable just yet. What we've actually done now is that we've added some logic that says that it's going to make use of this binding attribute called forced. So binding attributes use dot notation, and attributes are basically properties of this of the points that are going to be bound to these variables. So this binding attribute is not actually an attribute of the variable we've created inside the program, but it's actually an attribute of the structure where or B3 point. In fact, I don't believe this feature works for B3s, but we can definitely test it out when we do the live presentation, the live training. But in this context, this forced binding attribute is actually a property, an attribute of the point, not the variable. The variable is basically just a conduit or a gate for this attribute to actually be mapped over to the correct object in structure word solution. So how this forced works is not exactly the way you would think, and the only reason I'm gonna go over it is just because you might find some use for it. I know when I learned it, I thought, okay, well, I could use it for this or that, but to be honest, I've not used it yet on the field. But essentially what happens is, once this logic is true, this forced statement will basically assign the value of true to this binding attribute of this point through the conduit offered by this variable. And essentially, once this takes place, once this code executes, supply fan command is not going to become true. It's actually gonna stay latched to the last value it had when this code executed. So let me repeat that. Forcing here in the code, it's not exactly like this force operation where you can force the point to be in the state that you want it to be. That is not how the forced binding attribute works. The way the forced binding attribute works is when it executes, it latches the last value that this point had. And no matter what else happens in the logic, this logic will not be able to change that point state from the state that it latched onto when this forced binding attribute executed. So let's see the example of that. So right now we've got aux schedule true, and because unit state is 1, right, so I also had just removed some of the logic here that said that if unit state is 1, because you know, in a real world application, we wouldn't want this fan to run if unit state is actually 1. However, because we used unit state here to kind of make some proof of concept and show this feature and test how it works, I had to remove this line that used the unit state of 1 out of the program. But that was just so that we could test this feature. So unit state is 1, so this logic will have priority. That we're not in a forced state right now. There is no way to see this whatever state the forced binding attribute is at any moment, because as we stated before, this force is not the same as this force. So let's go ahead, and now that we're true, let's go ahead and show what happens. Just show that this logic is in fact commanding sfan command. And indeed it is. So we aux schedule is false, sfan request is false. Where before aux schedule was true and sfan command was true, now that is false, sfan command went back to false. If we make sfan request true, we should see sfan command become true, then back to false. So we've proved that we actually do have full command of this point's output or value through this code. This code is actually in control. Now though, if we go ahead and set this value to 0, we should see that this code now, since this Boolean statement or Boolean expression becomes true inside the if then this will execute, where before, since unit state was 1, this was evaluating as a false statement, and then therefore else was the code that would actually execute, keeping forced as false, the forced binding attribute as false, and allowing this code to have control of the point's output. Now, however, when we save, things change, and now this is a true statement, and sfan command that forced is assigned a value of true, and now the last value that we had, which was false, gets latched on. And you can see now that if we make this guy true, nothing will happen. SFAN command is locked into its last state by the use of the forced binding attribute. If we go ahead and turn SFAN request true, we'll see that it has no effect because this bit of code has lost control of the point's output after setting this forced binding attribute to true. Now if we go ahead and release that by changing the unit state to something other than 0, thereby making this statement a false expression, we will now see that this bit of code regains control again. So, as I understand, we were having some issues at some point during one of the projects that I was involved in, Poland, using being able to force outputs into place. We knew how to do it with B3 controllers by using priority overrides that are part of the BACnet standard and native to B3 controllers. However, we weren't sure how to do that on structure-aware native components. I believe that this is the way to do it. It's just not a very straightforward way of doing it. You just have to make sure that you add some underlying logic to make sure that when you are going to force a point into place in the I/O module on an ASP, you set the state to the state that you want it to be latched on before you execute logic that makes use of this binding forced attribute. Once we do the live presentation, we can absolutely go ahead and do an example that makes use of this and see if we can accomplish that. So that is binding attributes, the forced attribute. There are a number of other attributes. We have an overridden attribute, which would only be good for if we had an ASP or B3 to work with. I believe this actually only work for ASPs. So if we had an ASP to work with, we could use the overridden, and the overridden binding attribute will just give you status of the physical toggle or override potentiometer for analog and digital outputs on an ASP device. Or any kind of AS device. Then you'll have an offline attribute, which is also status of network connectivity between the I/O module and the device hosting the program. And then you'll have an invalid binding attribute, which is sort of what we will be testing right now.